Hi guys, this is CSG. So today I wanted to make kind of an introduction lesson, just so you guys can understand what I'll be covering, who I am, and what's going to be happening during the series. So basically, the series will consist of lessons in kind of uh, like organized lessons that like will be covering things. So it won't be just random things. I'll be covering each topic, and as the videos continue, the further we go during the series, the more complex the videos will get. So I'd highly recommend starting from the very beginning. Also, I'm currently a computer science student, and I will be covering topics within the theory of computation. I actually studied this last year, and it was one of my favorite subjects. So I'll be covering different topics within it. So I'll be covering just the course. Also, I have my email just on the right. If you guys look, I have my email attached. So if you guys if you guys have any questions, or if you guys have anything you want to ask, then you can feel free to email me. Um, I'll constantly be checking my emails for videos you guys might want to see, or if you have a problem, I could kind of just make a sample question video where I could just do the question and maybe it could help uh, other people as well, you know. So that's who I am. That's my email. That's what the series is going to be about. And today I'm just going to make an introduction video that will help you guys kind of understand what's going on. So if you kind of know what theory of computation is and like what's involved in it, you don't really need to watch this, but this is for anyone who's starting the series fresh. So I'll just get right into it. So we have to look at what the theory of computation really is. And before I actually continue, a lot of people have come to me and said that theory of computation is like the hardest subject they've ever come across, and that's actually not the case. And because I used to think that as well. So at the beginning, I was so overwhelmed by the notations and stuff like that that I was like, this seems impossible. But once you increase your understanding in the subject, it's honestly not that hard. And once you develop an understanding, it becomes more interesting to you as well. So hopefully I'll try my best to make sure you guys understand this subject, because I was pretty much on the same boat as you. So, and I'll just show you guys that it's actually not that hard. You just have to kind of in, put in a bit of work and just try to understand it rather than just learn it off. So we'll get straight into it. So let's look at the definition. So the definition of theory of computation is that the theory of computation is a branch that deals with how efficiently problems can be solved in a model of computation using algorithms. So this is basically saying that sometimes there are big problems we can't solve using small computers or calculators. So for those different problems, we use some algorithms and we check if we can solve these problems. Now, the question is, can we solve these problems? And the answer is yes. So we can solve these, but using abstract machines. And we'll talk about this further on in the series. And we'll actually be going through them using algorithms. So the theory of computation is something that helps solve difficult problems by using algorithms. And the theory of computation really helps you develop your algorithm like understanding, and really like it builds it up quite a bit, and it gets you thinking like a lot, which is very good. So as you can see here, just over here, these are the three parts that are in the theory of computation. Um, so the first one, let's look at the first one. So the automated theory and language. And don't worry if you don't know what these are. We'll be going a lot more in detail. This is just to show you guys what I'll be covering and what I won't be covering. So the automated theory and language, this is for like technical students and students who are kind of attending like college and want to know what theory of computation is. So in automated theory and language, it's very important, and we will be covering it quite a bit because it includes um, finite automata and push-down automata. And then computability theory, we also will be covering, and that's because it involves Turing machines. But this last one, we won't be covering it a lot. We'll touch on it slightly, but because it's more used for like research students. So anyone who wants to kind of further their knowledge in theory of computation, they kind of that's what like we won't need it really. But if you guys have any questions about it, I'd be more than happy to answer them. Um, let's talk about each one in kind of more detail. Um, so we know that automated theory and language is very important because it covers all types of automata. It includes finite automata and pushdown automata. And then computability theory is also very important because it involves Turing machines. Computational complexity theory is important, but we won't be touching on it too much because it's more involved around the research area. So let's kind of talk about AT and L, so automated theory and language. So to understand automated theory and language, um, we kind of have to understand what sets are to develop our knowledge in AT and L. So we have to understand sets. So, and what I mean by understand sets is kind of just like know what is a set. So understand what is a set, and do you understand notations? So the different notations that are used in sets, that it's very important to kind of just have a good understanding of them to kind of further talk about automated theory and language. So and then if we kind of look at this in relation to kind of the definition of theory of computation, we see that the different concepts that it includes are so strings. Just move it up a bit here. So it involves strings. It involves alphabets. It involves languages. I got my writing. It involves sentences. It involves grammar. It involves applications. I'll be going through grammar examples. I'll just do that just so I don't forget. Application. And it also involves, last but not least, automata. And I'll go through, actually I'll go through that first. So automata, like I mentioned before, it involves finite automata. And again, we'll be going through these in a lot more detail, so don't be worrying about anything right now. And then we will go through pushdown automata. We also will be going through Turing machines. That is a disgrace for them. Turing machine. Okay, and so we don't forget. So in depth, this is what we'll be looking at mostly. And other examples of grammar include so includes derivation. It also includes parse trees and other concepts. So parse trees concepts. So that's kind of the what we'll be looking at mostly. So that's kind of what the theory of computation is, and the definition of it, what we will be covering, what we won't really be covering, what each kind of section includes. If you guys want, we could start off with understanding sets, but I think that's a bit too basic. But if that's something you guys want to see, just let me know. That's my email there, so you can contact me through the comment section. I'll be reading through those, and you can also email me any questions or any help you guys might want. I won't charge. I do this just to help you because I know that I would have wanted someone to make a series where they kind of explain things step by step. Because sometimes on YouTube, when I was like studying this, and I had no idea what it was. I was actually I went to like different YouTube videos, but they were never in like order according to my course. So I kind of just wanted to have this for any students who kind of would have a similar syllabus to me. So I hope this helps. If you guys want me to upload this to like a drive, just let me know as well. But I feel like you guys just gonna take screenshots, so not too bad. So thank you guys for listening, and God willing, I'll see you in the next video. Thank you.